perform the floor cleaning or cloth folding or pressing our clothes. So these are libraries are present in this ROS, in this package management. Basically ROS is open source, so you don't have to pay. And ROS is made by Willow Garage. Basically the Willow Garage is the startup in Stanford University. Basically there they made this platform, and now the Willow Garage is closed, and now basically ROS is under the OSRF, Open Source Robotics Foundation, and it has the very good community, and you can use it. And now we should see the videos, ROS enabled robot videos, the robots which are using ROS. So you can see the name of that robot is PR2. Here it is basically it is making the pancakes or chapatis, and here it is traveling through a loop. You can see precisely how collaboratively it can, how imitating the gestures of Black Man, and how it is on the staircase. Move freely, how it is dancing, these robots. These all robots have the ROS. They are using the ROS platform. Now move on. Now we talk about PR2. Basically, this is the first robot. In 2007, this is the first robot which uses ROS first time. Basically, the specifications of this robot has a cost of $4 lakh. There are 2 servers in it, 2 computers, i8 or i7. It has the 2 times of 24 GB RAM, 7 cameras, 2 laser range finders. It has 4 degree of freedom arms of 2 types and 3 degree of freedom wrists. And it has the only directional base, so that it can move freely. Okay, now we should say that we should see how PR2 working in unstructured environment. Basically, this PR2 robot is folding the clothes, and how quickly it basically the folding. So how useful can be the ROS for making the robot applications like this? Basically, now we discuss about PR2 having 3D sensors. In this simulator, I am showing you how PR2 having the sensors in the head, its head, and how it visualizes the audience around this with the help of its sensors. You can see that it simulated that how can we easily simulate the applications with other robots. Basically, here the audience is sitting, and how it visualizes that the audience is sitting in front of it. Now let's discuss about the PR2 power consumption. Basically, first plot is computer. When the PR2, basically you have seen that PR2 having 2 servers. So with the help of 2 computers, it is getting 400 watts of power. But if we offload that compute systems to the cloud, and we only have the motor, then we only require 200 watts of power. Now basically ROS enabled hardware, there is a turtle boat, the name of, you can easily purchase online, it is affordable, and basically it explore your house on its own, build 3D pictures, bring you food. Basically the food is setting up here on its head, and you can just give the command through your terminal, and that you want to communicate with the food with someone, you can help in that. And it comes with an open source SDK based on ROS, advanced capabilities like mapping and knowledge, and you also can navigate your whole house with this hardware. It's also built 3D pictures. It is very useful thing to, if you are really interested to research in this field, you can independently work on this hardware and make more applications. Now we discovered ROS on Android. If suppose we want to integrate ROS with Android smartphone, how it happens? Basically, ROS framework written in pure Java called ROS Java. In terms of ROS is also the library called Android, through which we can integrate the Android smartphone with this ROS, and it's also Android compatible. It's also open source. So let's see the video. Basically, how it's happening. Basically, this man has the has integrated with the mount of head of this PR2 robot. So basically, as this head is moving, as the tablet is moving, the head is also moving. So it's integrated. You can integrate easily. Now the conclusion. Basically, we are offloading the task from robot into the cloud in terms of memory and processor. As we have the Google services on the smartphone, in the similar manner, these services are transferred to the robots. PR2 robot is performing such services in terms of object recognition with the help of Google Goggle servers. There is a server called Google Goggle servers, through which it can identify easily the images around it. If we remove the servers from the PR2, then we are doubling the battery life of PR2 for 4 to 5 hours. That's the main advantage. ROS on Android gives us the service in which we can control the robot from our smartphone also. Now here's the references. These are the research papers you can go through online, through which I have made this presentation. Here's the cloud architecture challenge and application. The Google Goggles research paper is there, and Point Cloud library, and Vero Garage PR2. Yes, references. Thank you.
Questions?
Is it proactive or done?
Just one.
Just wanted to know the difference between proactive and dynamic routing.
Proactive routing means, can I have a marker? Basically, we have routing tables. This is also the routing table. Basically, the routing table has the routes in it. Basically, through which destination routes are basically the destination. Suppose we have the robot here, and it is communicating with this robot. Are you seeing? Basically, the information how that robot will communicate with this robot, the information about the routes, the information basically in terms of packets. If you study the networks, you can easily know. Basically, there are some types of information that previously we should have in terms of proactive routing. We by default have the information through which robot we have to communicate. That information is previously stored in this routing table, through which it can communicate easily with the robot. And in terms of dynamic routing, dynamic routing means we don't have the previous information to our destination in this routing table. We will make this routing table dynamically when that thing will occur.
You asked us what is a robot, but you never told us whether we gave you the right answer or what exactly is the definition of a robot according to you. What is a robot?
Basically, the many types of the average scientist and researcher has given its own definition.
Any accepted standard? There is no accepted standard.
There is accepted. There is no till now there is no accepted standard because they are also we are researching in that domain, so we can't presumably can say that this is the definition of robot. So it is something like hypothetical. So I just want to know how much have you got. It's a robot.
You also mentioned machine in cloud robotics. You mentioned machine-to-machine communication along with cloud communication. So I found that very interesting that it could communicate with the cloud, but I didn't understand what was the need for both machine-to-machine communication as well as communication with the cloud.
Basically, suppose if we talk about military operations, they are very sophisticated methods. In that environment, the theory has come up that the robots will work simultaneously to maybe perform the rescue operation, or maybe an earthquake has come up where the robots has to find out where is the survival. So in that case, robot has to communicate with other robot also with the cloud, because the cloud has the processing and memory capabilities. He has to use that capabilities. So that's why.
Can't two machines communicate indirectly via the cloud since both are connected to the cloud?
Basically, this is the shortage. Basically, why we want two robots. Basically, these two robots, and here is our cloud. Okay, and it is talking with each other, and also, and you are saying that by one.
No, by this.
Why there is a cloud?
No, by this communication, machine to machine.
Okay, by this communication. Okay, I explain you that. Suppose there is no communication. In that case, what will happen?
It will communicate through the cloud.
Means that robot. Suppose this robot has taken the image of something and it experiences something from it. Then that experience knowledge will transfer to the cloud. Okay, and maybe yes, maybe you can use maybe the knowledge is transferred there. Maybe that knowledge is used by this robot. But for the safe side, we can, if we have the communication with these we can also, yes, you can take it, but research is also going on. I am just
I think one of the reasons is security.
yes, security.
I think like Indian military is always machine communication, like the DRDO they use machine not the cloud because of the security purpose. If you find, because Indian military don't want their data, if they push it to the cloud, it can easily hack. Anyone can. Because
No.
Chinese, they are continuously attacking for that.
No, right now we are using OS 2.0.
No, by cloud we don't mean a public cloud. It can be just a server of that same organization.
That's what I said, you can transmit machine to machine. There is no need of any
I'm
cloud.
saying
Because
cloud
it's faster
itself,
communication
cloud
technique.
itself need not be a public cloud. It can be a cloud of just that organization. It is not the internet. It can just be a LAN system, a remote LAN system that is being used. I think the two reasons why machine-to-machine communication, in my experience, would be there is first of all latency. The latency that's there.
How fast?
Yeah, and sometimes if you don't have connection back to the internet, if you have short-range communication device, so via Bluetooth or via RFC radio signals, those are, according to me, only the two reasons why we would prefer M2M.
They can work collaboratively.
But this does increase the cost of the system because we've researched over this fact. It's far easier, far cheaper to send data to the cloud and then take it.
Yes, I will get back to you.
Sure.
Later.
You said two structure of robot.
Yes.
Structure and structure. The structure is a task is auto-defined and robot is working. And unstructured robot is also defined a define a task as a human or computers. So how to different structure and any structure?
Basically, there is also third type of system structure is also there, which I have not mentioned in this PPT because I don't think it is maybe the relevant because it is called semi-structured. In that, it is halfly the in unstructured environment, halfly the structure.
And then first robot is PR2. You know why name is PR2?
Personal logo.
And two,
Yeah.
and two. PR
Two.
personal robot and two.
Here to research on.
Maybe second version.
Yes, maybe. But when
This is PR first time.
when I studied that paper, there is no mention of PR.
From my college days, I have always listened that artificial intelligence is very much harmful to human environment. In future also, we can are not able to face the artificial intelligence or sort of. What do you think about in future we can use it in very structured manner, artificial intelligence, neural networking or fuzzy logics. And I have also seen that you have not mentioned about Asimov.
Basically, yes, before giving the presentation, I was just thinking that maybe I should give that thing. But I missed it. I realized it.
Do you know that KUKA robotics that you have mentioned? KUKA.
Kuka automation.
KUKA. KUKA have also some hands in building Asimov. In movie Koi Mil Gaya, they have used Asimov.
Asimov is first introduced by the Honda.
Mechanical robots.
Any other questions?
Any other question?
Any other questions?
If many products present here, so just like how robots grabs individual products. आपने एग्जाम्पल दिया था कि एक बॉटल रोबोट उठाना तो कई प्रकार की सेम प्रोडक्ट्स एक जैसी बिल्कुल सेम स्ट्रक्चर हाउ मेंशन ओनली दिस प्रोडक्ट इज देयर
Basically, in that thing, we will use the service of the cloud. At what attempt we should take that call? At what angle we should? Because every bottle has also its own design. There is not that always we have the same design of bottle. Maybe if I have to if I have to call the robot that we have to just lift at this monitor, then in that case we will just take the photo and to the cloud, and that cloud will help it at what angle of its hand and what type of degree of freedom we should choose to lift that angle.
Suppose you gyroscope.
Yes, sir.
जायरोस्कोप में मतलब अपनी इमेज को जैसे वीडियो है तो अपनी इमेज को वो रीसेट करता है
You basically photo with the help of basically when you are seeing the photo in that angle, that photo is come in that landscape. When you rotate it, come in that angle. So basically, it's the work of gyroscope. And the other use of gyroscope is in the aeroplane. Basically, how aeroplane know that it is standing straight or in what direction he has to move. There is also gyroscope visible.
So how does it help in robotics?
Robotics, basically it is in robots, this PRO has the only directional base. I don't think so here it is using, but if the other design of robot, where it has the bipedals, I talk about bipedal robotics. In that case, how will you stand upward or so that you can't topple? There gyroscope is helpful.
Any other questions?
Akshay Kumar, there's same type of buttons, ठीक है, multiple buttons in round. So which one I want to pick up this one and multiple buttons, same color, same type, same structure. So how it feel कि इसी को pick करना है?
It depends on the what color. Basically, the photograph it is taking, and what color is really wanted. We wanted. Basically, we are operating that robot. We are to robotic one. Basically, we are operating through our laptop or desktop. We are giving that the command to the robot. That type of that color of robot you have to pick.
If there are two
Text.
bottles with same color, with same type, with same structure, then
It can calculate distances too. When it can recognize image, it can calculate distance and accordingly it can take decision.
if there are 10 bottles.
Now it can calculate distance.
Same color, same.
When
It cannot, a robot can, it depends to
Maybe
what
it
capability you
also
are building a
calculates
robot.
some
If you
mathematical
build a
calculations.
robot
It also
to
calculates the
these
optimal
capabilities
path.
also.
What is the shortest path to get that item?